Remember that in a binomial probability distribution, we are mainly interested in finding the probability of a specific number of successes in a given number of trials. So this was our binomial distribution. Now, suppose you're interested in knowing, for example, what is the probability that a student miss 3 sessions of class in a quarter? We are interested in answering these types of questions. What is the probability that a student misses 3 sessions of the class in a quarter? To answer these types of questions, we use Poisson distribution. So let us go over the basic definition. Poisson distribution is a discrete probability distribution for a discrete random variable x. It satisfies the following condition. First of all, the experiment consists of the counting of the number of times x as an event happens in a given interval of, it can be time, it can be volume, it can be area, and so on. Number 2, the probability of the event is the same for each interval. Is the same in each interval. Number 3, the number of happenings in one interval is independent of the number of happenings in other interval. Independent of the number of happenings in other intervals. Now the probability is defined as P of x equals to mu to power x times e to power negative mu divided by x factorial. As you remember, E as Napier number is approximately 2.71. (82.8) and so on. Mu is the mean number of happenings per interval unit. Mu is the mean number of happenings in one interval. We can also use parameter notation and write it this way. Just a quick note for you. Poisson distribution with parameter mu can be represented this way. P of x colon mu, which is e to power negative mu multiplied by mu to power x divided by x factorial. And remember that x takes on values 0, 1, 2, 3, and so on. One quick example for you. The number of accidents on Highway 17 in California each day basically follows a Poisson distribution. Let mu be equals to 3. So this is the average of happening in one interval, so which is one day. Question is, what is the probability of having no accident? So basically, since it's a Poisson distribution, we already have all the missing information. The probability that x is equal to 0 with mu equals to 3 is e to power negative 3, 3 to power 0, divided by 0 factorial. As you remember, 0 factorial is equal to 1, so you have 1 times e to power negative 3. If we use our calculator, it gives us about 5%. So the probability that having no accident on Highway 17 is 5%.